All right, in this video, we are going to evaluate these trig expressions here without a calculator. Let's take a look at the first question over here. So if you look at this question over here, you can actually evaluate it because we can find cos 2 pi over 3 as an exact value using our special triangles. But you can also notice that this is the formula for cos 2 theta, which is 2 cos square theta minus 1. So using this formula, I can turn 2 cos squared theta minus 1 into cos 2 theta. So I'm going to do the same thing over here by multiplying 2 times this angle over here. So this is going to turn into cos of 2 times 2 pi over 3, which is cos of 4 pi over 3. And now I can evaluate this using my special triangles. It's going to be a bit easier than evaluating that instantly. So I know that 4 pi over 3 is in quadrant number 3. I guess I didn't need a triangle there. Probably should have just drawn a line. I know that the full principal angle over here is 4 pi over 3, which means that the acute angle here is just 4 pi over 3 minus pi, which is just pi over 3. And now I know pi over 3 is one of the angles in the special triangles. Opposite of pi over 3 is root 3. But since this is the negative y-axis, it's actually negative root 3. Adjacent is negative 1. And hypotenuse is always positive. My hypotenuse is 2 for this special triangle. So cos of 4 pi over 3, cos is adjacent over hypotenuse. That's just negative 1 over 2. Let's go to this second question over here. Now, this one cannot be evaluated initially. You have to use a double angle formula to solve this. I know that sine 2 theta is equal to 2 sine theta cos theta. So I can use this to simplify this by just multiplying this angle by 2. So 2 sine 11 pi over 12 cos 11 pi over 12 is the same as sine of 2 times 11 pi over 12. And this can simplify. The 2 and 12 can cancel to give me 1 and 6. So this is just sine of 11 pi over 6. And now again, I can use my special triangles to solve this. 11 pi over 6 I know is in quadrant number 4 over here. The principal angle is 11 pi over 6. So the acute angle over here is 2 pi minus 11 pi over 6, which is pi over 6. Opposite of pi over 6 is 1, but since it's the negative y-axis again, it's negative 1. Adjacent is root 3, and hypotenuse is positive 2. So I know that sine of 11 pi over 6 is just opposite over hypotenuse, which is negative 1 over 2. And let's take a look at the third and fourth question here, which are pretty similar to the ones we did. So here we have cos square 7 pi over 8 minus sine square 7 pi over 8. We can use the equation cos 2 theta equals cos square theta minus sine square theta. Theta is just 7 pi over 8 in this question. So this whole expression is going to equal to cos of 2 times 7 pi over 8. The 2 and the 8 can simplify to give me 1 over 4. This is just cos of 7 pi over 4. And I'll use my axis to solve this. 7 pi over 4 is in the fourth quadrant. Principal angle is 7 pi over 4, which means that my acute angle is 2 pi minus 7 pi over 4, which is just pi over 4. So this is the second special triangle. Opposite of pi over 4 is 1. Since it's again the negative y-axis, it's negative 1. Adjacent is positive 1. And hypotenuse is root 2. So cos of 7 pi over 4 is adjacent over hypotenuse, which is 1 over root 2. But if you rationalize, multiply root 2 on the top and the bottom, it's just a root 2 divided by 2. And let's go to this fourth and final question here. I have 1 minus 2 sine square pi over 2 for this one. So again, this is a formula for cos 2 theta, which is just 1 minus 2 sine. I don't know why I wrote cos, it's 2 sine square theta. So again, I'm just multiplying this angle by 2 to turn it into cos of 2 times pi over 2. These 2's cancel, so this is just cos of pi. Cos of pi can be solved using a cosine graph. Cosine graph looks like this, where this is 2 pi and then pi is here in the middle. So cos of pi is just this point down here, which is a value of negative 1. My final answer for this last one is just negative 1.